We now turn to prices within a city. Let's start with a simple world. Every person lives in exactly one house. The city population is fixed at 100,000 households. The city is a circle, and everyone walks to work in a giant skyscraper at the center of the city. It costs a fixed amount per mile of walking. To start with, we'll assume that every house uses exactly 1/10 of an acre of land, and that we don't need messy things like roads or other forms of infrastructure. Don't worry, I know that I'd lose at SimCity if I tried to make this kind of city. Transportation costs rise linearly with distance to the city. What's going to happen to the cost of housing? Well, the spatial equilibrium concept means that the housing costs must fall to exactly offset these transportation costs. So we can draw a declining line for housing costs that has exactly the opposite slope of transport. You add them together, you get a fixed total cost of living in the city that is exactly equal to the cost of housing at the center of the city, where you don't need to commute at all. And if commuting gets more difficult, so the cost of transport slopes up more sharply, then housing costs will fall down more sharply. You can see that as the transport costs pivot up, the housing cost curve pivots down. What determines the intercept of the housing cost curve? The price of land at the edge of the city, where the land is presumably used for farming. This is the Alonzo-Muth-Mills model, justly famous throughout urban economics. In this form, it merely predicts that housing costs will decline with distance from the city in a way that perfectly offsets commuting costs. Can we jazz it up a bit? Sure. Let's allow two transportation technologies. Walking, which looks just like before, a ray coming out of the origin, and owning a car. Owning a car includes some fixed costs, like the down payment and insurance costs, but then the per-mile commuting costs are lower than walking. So it has to have an intercept above the origin, but then a flatter slope. There will exist a distance from the city center at which it makes sense to switch from walking to driving. So if people aren't idiots, that's a standard but controversial economics assumption, they're going to choose the transportation technology that minimizes their total commuting costs. That means they're going to choose the lower lines, walking when they live closer and driving when they live farther away. Total transportation costs will be the inner, concave hull of the two lines. What about housing costs? Well, the same spatial equilibrium logic applies. Total housing plus transport costs must be constant. Consequently, housing costs will first drop sharply with distance in the region where people walk, and then they level off and decline more slowly in the region where people drive. This model is generally supported by the data. Prices are higher closer to the city center than on the edge. Of course, there's a lot that's wrong with the model. People don't commute to one place. People care about locations for reasons other than commute time. But as a starting point, the Alonzo-Muth-Mills model is simple, and it does pretty well with a lot of the data.